Hi guys. So today we're going to take some vectors and do some operations like adding, subtracting, multiplying, things like that. So the first thing we're going to do is we're going to look at a vector where we know the starting and ending point and we want to find the component form. Now remember component form, those are the pointy brackets with an x and a y. So to figure this out, I'm going to start by drawing a picture. That might make it a little bit easier. So we're going to go ahead and plot the point 4, 7. So there's 4, 7. And then I'm going to plot negative 7, 13. Which is going to be all the way over here. Now we can tell the direction by the way the vector is written. Since it says PQ, P is the starting point, the initial point. Q is going to be the ending point. So that tells me my direction goes this way. So we're going to start by component form, finding that x component, finding that horizontal distance. Well, because we're going left, it's going to be a negative, so let's be careful not to forget that. And the total distance that we moved, if we count all of that up, we've moved 11. Vertical distance up and down, we went up, so it's positive, a distance of 6. Now the way you can get this without drawing the picture is think about you would do the ending point. So we'll call this x1, we'll call this y1, we'll call this x2, and we'll call this y2. I could take y2, we'll start with x's. I can do x2 minus x1, and then y2 minus y1. So that's how I could figure it out without drawing the picture. Okay, so if we went backwards here, negative 7 minus 4 is a negative 11. If I did 13 minus 7, I would get 6. All right, so now let's go ahead and do our magnitude and direction. So now that we know component form, this is really just review from last class. The magnitude here would be the square root of negative 11 squared, remember in parentheses, plus 6 squared. Plug that into a calculator if you need to. We would get the square root of 157, which should not simplify, just square root of 157. Find that angle. Then we've got, remember, tan inverse. So my theta is tan inverse y over x. So that's 6 over negative 11. Now, if I plug this in, again, your answer probably won't make sense based on the picture that we have. Okay, think about if you took this angle that we drew. I don't have notability, I wish I did. If I took this and I just moved it over here to where it's starting at 0. Okay, we can see where that angle is. It's negative over 11 and up 6. That angle there looks like it's somewhere between 90 and 180. If I just plug this into a calculator, I'm going to get negative 28.61. Okay, that doesn't look like it because, again, remember, if the x is negative, if it's in quadrant 2 or 3, we have to add 180. So it's 151.39 degrees, which makes more sense for the picture that we drew. All right, so now we're going to look at some more similar operations that you're used to, adding, subtracting, and multiplying by a constant. So the way we add vectors, we're going to look at this visually first, and then we'll do it algebraically. And it's actually easier algebraically than visually, I think. So when we add a vector, we add them from head to tail. So what that means is we take one vector, and then the next vector's head goes on the next vector's tail, and the next vector's head goes on the next vector's tail, something like that. So we kind of just you draw one, then you add one, and then you add one, and then you add one, whichever ways you're going, and that's how you would add up your vectors. The way it works, you're going to then find the new vector. Okay, the new vector is going to start at the original vector's start, the original head. Okay, it's going to end at the new vector's or the final vector's tail. So what we get when we add them together, that is called our resultant vector. The resultant vector. Okay, so if we take one and add it, we then find whatever new vector there is. So let's go ahead and do an example of this before we answer these next questions. So this says we're going to show what this looks like algebraic, or so what it looks like graphically. All right, so I'm going to start with vector u. So I'm going to take this u vector, and I'm going to go ahead and draw it over here. Now, if you have notability, you should be able to draw it here, and then just kind of carry it over. Now, I'm not using notability, so I can't do that in mine. But I'm going to go ahead and just start it right here. So I'll just move it somewhere in the middle so I have some space. So I'm going to go and draw this original vector which goes a distance of 5 to the side and 2 down. Okay, so that is my u vector. In order to add that to a v vector, what I would do then is I would, at the tail of u, I'm going to draw v. So v goes like that. Now, if I was only adding a single v, what I would do to find my answer then is I would draw a new vector from the original start to the ending tail. So this new vector, that would be what we call the resultant. Okay, but this one's a little different because it says 2v. Well, if there's 2 v's, what we're going to do is, again, draw another v. So from that tail, I'm going to draw the new vector's head. So now I have 2 v's. That 2v that's written in there, that is what's called scalar multiplication. Okay, that is scalar multiplication. What it does, you're multiplying by a constant. Okay, it's going to increase that vector's length. All right, so now let's go ahead and draw out the resultant vector here. So I start at the original start, end at the final end. So what's in purple is my answer. So let's find the component form of that final one. So I've gone over 1, 2, 3, 4, 5, 6, 7, and up 2. So in component form, that new vector, the resultant vector, is 7, 2. All right, now, when we talk about subtraction, what we're really looking at are what are called negative vectors. So a negative vector is a vector that goes 180 degrees in the opposite direction. So if I were to do a negative v, it would go this way. A negative w, it would go this way. Negative u would go that way. Okay, so those are negative vectors. So let's go ahead and try the next one. So 2u. So I'm going to start by drawing 2 u's. So here's 1. Again, we went over 5 and down 2. And because it's 2u, we're going to make 2 of them. So there's my 2u. All right, let's go ahead and it says minus w. So what that really means is the negative vector. So the original w goes right and down, so we're going to go left and up. So I'm going to go left 2 and up 1, 2, 3. And that is my negative w. This is my 2u. So my resulting vector here, I'll do it in red this time. Whoops, wrong direction. So what's in red, that's my resulting vector. So if I count that distance, it looks like I've gone over 1, 2, 3, 4, 5, 6, 7, 8. And I've gone down 1. Now I told you guys the graphical part of this, doing this visually, is actually harder than just doing it algebraically. Because the way you would do this algebraically is actually about the way you would think to do it. So what I'm going to do is show you guys how to do this without drawing the picture. Okay, I'm going to write the component form of each of these vectors. So let's do u. U's horizontal component is 5. U's negative component is down. U's y component, that just sounds strange, is negative 2. Let's go ahead and do w. The horizontal component, I went right 2. The vertical component, I went down 3. And then let's go ahead and do v. The horizontal component there, I went right 1 and up 2. So those are the component forms of each of those. Well, if you think that you're going to take u and add 2v, all we're going to do is that operation with each component. Take the x's, take u's x, and we're going to add it to 2 times v's x, which is 7. It's exactly what we got here. All right, let's do the same thing with the y component. I'm going to take v or u's y component, and I'm going to add it to 2 times v's y component. That gives me negative 2 plus 4, which is 2. So let's try b. Okay, 2u. So let's just go ahead and multiply it by 2. That'll be 10, negative 4, minus w. W is 2, negative 3. Well, 10 minus 2 is 8. Negative 4 minus negative 3 is negative 1. That's my answer. So much easier to actually do these algebraically than Graphium. But Graphium kind of helps us see what's happening. So let's do some more of these, but again, we're just going to do it algebraically. We're not going to draw the picture here. So it gives you 2 vectors in component form, and it wants you to find the resultant vector. So u plus v. I am just going to take negative 2, 4 plus 6, 1. Add them up, 4, 5. So it can be that simple. It's a little bit hard to see visually. All right, u minus v. Let's take u minus v. Negative 2 minus 6 is a negative 8. 4 minus 1 is 3. All right, let's do one more, but let's do a little bit of extra review with it. All right, so we've got u and v. We want to find 3u minus 2v in component form. All right, so component form, again, just what we've been doing. So let's do 3u. That's going to be 15, negative 12, and then minus 2v. So that's negative 6, negative 10. 15 minus negative 6 would be 21. Negative 12 minus negative 10 would be negative 12 plus 10, which is negative 2. And I said 21, but didn't write 21. My comma turned into a 1. So that is your component form of the resultant. Well, now we want to find the magnitude and direction. This is just reviewing what we did last class. Remember magnitude, Pythagorean theorem, 21 squared plus negative 2 in parentheses squared. If you need to plug that into a calculator, you can. We would get the square root of 457. For direction, we're going to use tan inverse y divided by x. Again, plug that into a calculator. And we are going to end up with negative 5.44 degrees. Now, again, think about this. This actually does, we don't have to add 180. The x is not negative, and this would be in the fourth quadrant. If I go over 21 and down 2, I'd be going backwards about 5 degrees. So negative 5.4 degrees actually is okay here. All right, so let's try one more. This is going to combine kind of everything we've done so far. So what we're going to do is we're going to take magnitude and direction. We're going to find component form. Then we're going to add them together. And then we're going to find magnitude and direction. So this just basically reviews everything that we have done so far. So let's start by finding the component form of u and v. So remember, component form is going to be an x comma y. So we need an x and a y. All right, so u, we're going to find the x component for u. Remember, the x component is magnitude cosine the angle. The y component will be magnitude sine the angle. And this is one you don't technically need to use a calculator on because these are unit circle values. So 270 would be down here. So your x coordinate would be 0 and your y coordinate would be 1. Now again, if you use a calculator check, negative 1. If you use a calculator check it, that's okay. But I would get the component form here then to be 0, negative 2. Let's go ahead and do it for v. So same thing, let's find the x component. Magnitude cosine 150. Again, this is a unit circle one. So if you use your unit circle, you can find that this is negative 2 root 3, or if you plug it into a calculator. All right, let's do the y component. This would be for sine 150. Again, unit circle value, that would be 1/2, so that would be 2. So component form here, negative 2 root 3, comma 2. Well, now that we have the component forms, we can add them together. So if I take those and I add them, I'm going to get my resultant vector. 0 plus negative 2 root 3 is negative 2 root 3. Negative 2 plus 2 is 0. So that is my component form of the resultant. Now we're going to find the magnitude and direction of the resultant. So lots of stuff we're doing here. This is kind of getting us ready for what we're doing next class as well. So the magnitude here, Pythagorean theorem, negative 2 root 3 in parentheses squared plus 0 squared. Well, since it's plus 0 squared, if you think about that, okay, you're just squaring and square rooting the same number. Your answer is just 2 root 3. Now let's find direction. So to do direction here, I would do tan inverse y divided by x. And if you think about this, 0 divided by something, that's 0. Tan inverse of 0, the calculator is going to tell you 0. But again, this is negative. We have to add 180, and it's 180 degrees. Again, if you think about how this looks, it's going to make a lot more sense. Okay, so negative 2 root 3, 0. If I were to graph that, I'm going negative and up 0. That falls on 180 degrees. think about your original questions too. Okay, 270, if I'm going a distance of 2 here, that is your angle. That's why you got 0, -2 for the component form for this angle. So while you don't have to draw pictures for these, sometimes it's helpful to help you figure out if your answer makes sense. All right, what we're going to do next class is just some applications that's going to use a similar process to what we did on this last question.